Now it is the turn of Professor Sacerdoti design experiment.
Well, this is a usual thing, usual film you have seen when we switch from. Well, let me first thank Professor Santilli for having invited me and the Repubblica di San Marino for having supported my stay. I will talk about a series of experiments that are being done at CERN that are exactly opposite as LHC because they are based on the antimatter decelerator. So there are 4 groups of people working on small experiments with not so many people as LHC experiments, working on antimatter and precisely on anti-hydrogen creation. One of the experiments deals with anti-hydrogen gravity measurement, and the other ones deal with CPT verification, that is, verify that the energy levels of the anti-hydrogen are exactly the same as the energy levels of hydrogen, the hyperfine structure, and so on. Let's see if... Perfect. Avanti. So this is a design of the antimatter decelerator layout. So here, from the proton synchrotron of CERN comes a bunch of protons with 10 at the 13 protons per bunch. These bunches go against a target, and as Santilli put in doubt, but I don't know, some antiprotons are supposed to come out. Antiprotons are supposed to be selected here, and they are put on a decelerator. They are injected at 3.5 GeV because these protons here arrive at 28 GeV, and there's a process of deceleration and cooling. So opposite to LHC, to go from 3.5 to 0.1 GeV. There is electron cooling here and stochastic cooling. There's a whole system until we get to 0.1 GeV here. The antiprotons are extracted at 5.3 MeV with bunches of 200 nanoseconds. And feed the experimental area. You see there are various experiments. ATRAP is one of them, Athena is the other one, AGES will be in this area. And this is an improvement project in 2012, next year, which will still decrease the energy of the antiprotons that get to the experimental area, so to help experiments produce. This is a picture of the layout. I will briefly go through the experiments which interest us a little bit less, which are the ones that the ones on CPT. This is alpha. And this way, all these experiments are based on traps of magnetic and electric traps that on one side trap positrons and on the other side trap antiprotons, and then changing this potential, you succeed in having positrons and antiproton mix and create antihydrogen through a very refined, that I don't want to go into details because we are very late, and the number of confinement that has been reached, you see the trapping rate, and the experiment has arrived of confining the antihydrogen that has been produced for a period of 1,000 seconds. So it has having, so the first thing you need to have is a certain number of antihydrogen trapped in an area to be able with lasers to excite them, and that it will be very interesting to see what happens, excite the antihydrogen, and see the lines of emission, and maybe we can see if this is photon, antiphoton, what will happen. This part of the experiment has not been done yet. So, Asakuz, this was, wait, yeah. Asakusa, it's another atomic spectroscopy and collision using always slow antiprotons, but this always also goes into creating antiprototic helium atoms, that is an antiproton, an electron, plus an helium nucleus, always for testing CPT, and then they will analyze anti-hydrogen ground state hyperfine splitting measurements, and cross-section and nuclear cross-section. So there's all a new physics based on the availability of anti-hydrogen atoms. This is the conceptual, the experimental setup for the ground state hyperfine transition measurements, which is rather complicated. There is a cusp trap, a sextupole magnet, and this H-beam. This here, there will really be an anti-hydrogen beam and an anti-hydrogen detector based on, and this is the cusp trap using anti-Helmholtz coils with excitation anti-parallel. This is a whole arrangement that I don't want to get through to be able to have an intensified anti-hydrogen beam with high-speed polarization and low field seeking to be able to all these things have been extracted from publications that you can find on CERN website. You can find, if you go on website, you can find all the details and the technical details of these experiments. ATRAP is another experiment in which you have cold antiprotons are accumulating in pentnic traps in a 1.3 Tesla solenoid. The antiprotons always come from the antiproton decelerator, and here you have a positron accumulator where you arrive from an Na source. They come here and they get mixed and produce anti-hydrogen. How are anti-hydrogen measured in all these experiments? They are detectors of the annihilation, because these anti-hydrogen atoms migrate, touch, if some of them touch the border, or they turn off the trap. They turn off the trap, the anti-hydrogen electric field, anti-hydrogen go to the border, they are annihilated, and they measure the gamma rays, the photons that come out on the two sides, and they can find out exactly where they were. This is a description. This is one which is more interesting for us because it can be a competing experiment to the one that Dehaene has explained, and it is to measure first gravity, then interferometry and spectroscopy, but the first objective is to measure gravity. And the creation of anti-hydrogen is rather different from the other ones. We have always an antiproton beam arriving from the CERN antimatter decelerator. We have positrons coming from a normal positron source. Both have to be reduced to almost still. They are at micro-Kelvin temperature, so very, very low temperature. And the positrons go onto a target, a silica target, we will see in detail, where positronium is created. And positronium is excited by a laser, to a high Rydberg level. And once it's created, it's diffused to the antiproton trap. Here they are the antiproton as still as possible with a maximum speed of 40 meters per second. They are there waiting for the positronium. And once the positronium hits this cloud, we will see the reaction, anti-hydrogen atoms are created. These anti-atoms are created at a high Rydberg level, so there is an electric dipole, and one can accelerate them through an electric field. So this is a so-called beam, a group, a bunch of, well, it will be one, we will see, it will produce one anti-hydrogen atom every second. this will be accelerated in this way. And this is a Moiré deflectometer. We will see in another thing. And this is a position-sensitive detector. This is overall. And so the reaction is this one. Antiproton plus positronium, but excited positronium to a high Rydberg level will produce an antihydrogen to the same high Rydberg level plus an electron. So the process is produce ultra-cold antiprotons at millikelvin, accumulate positrons, form the PS, then laser excite the PS to get Rydberg PS, because otherwise the PS annihilate immediately. If we get Rydberg PS, we lengthen the lifetime of the positronium, and then form Rydberg cold antihydrogen by this reaction, form a beam using an homogeneous electric field to accelerate the Rydberg, and then the beam flies towards a deflectometer, and which will, this is a deflectometer with two levels of gratings. It's and here this is a position-sensitive detector. This kind of deflectometer will accept the atoms that fly horizontally, but anyway makes a diffraction, a classical diffraction. This is not a quantum deflectometer, it's classical diffraction fringes, that if there is gravity will go down, and if there is anti-gravity will go up. There are also some theories based on the component hypothesizing a scalar and vector component of gravitation that say that it could fall with a G which is different from the normal G. So we will have to measure whether it goes up, it goes down, or whether it goes down with a different acceleration from the normal one. There will be a 500-second accumulation time, a bunch of 20 nanoseconds, and well, this I have already said. There will be the G measurement. Let's see the next slide. How is positronium created? The positronium creation is based on silica, probably aerogel. Aerogel is a product that was produced by NASA to capture the vapors from comets. The positron gets in this microchannel, natural microchannel, and get kicked out and collides with electrons on the surface and create positronium atoms. As soon as the positronium atoms come out of this little target, which is 1 centimeter for 1 centimeter, there is a laser. There is a laser that will excite them to a high N25 Rydberg level. And here they will mix with the antihydrogen and produce antihydrogen B. The cross-section of this reaction goes with N to 4. That's why if we have a high Rydberg level of the positronium, we will get the experiment will get more antihydrogen. The travel distance is only 2 millimeters, and not only, but the time of life of the positronium, the Rydberg level, is much longer than the normal positronium, so it has time to arrive to the antiprotons. This is to excite positronium from the basis N1 to N equal 25 this is what will happen, the line width, and it will need 2 different lasers to 2 different frequencies of laser. This is the basis of antihydrogen acceleration based on the fact that these are the energy of the anti-atom in an electric field, and if the excited atoms are moving in a region where the amplitude of the electric field is changing, then the internal energy changes accordingly, and that's how they will be accelerated because it's a high n, and so they will be accelerated. So one could detect the normal fall or not fall of the antihydrogen. Unfortunately, the distance is too small. We don't have a 100 meters, so we can't detect that directly. Not only, but the antihydrogen has a radial velocity, and so this way it wouldn't be possible to see and detect the variation. This is the reason why a moiré deflectometer has been added, and this distance will be 20 centimeters, 30 centimeters, this will be other 30 centimeters. There will be an interferometry, and so it is this interferometry that will be measured, because the delta of every atom will be measured as a time of flight. It is known exactly when it is created, because there is a bunch every 29 nanoseconds. So it will have to be measured when the antihydrogen hits the target, the sensitive part of the target. The time of flight will be calculated, and then the move of the fringe up or down will determine G. So there will be a series of measurements of the time of flight of the different antihydrogen atoms, and there will be a fit. Consider that the objective is to create one antihydrogen atom every second, and the experiment will start for a month to have sufficient number statistical evidence, and that the error will be something like 10%. I don't know. So we will get, the experiment will get a 10% error. So the conclusion so this will produce a beam of cold antihydrogen. The cold antihydrogen will be accelerated. It will go through a moiré deflectometer and then measure the fringe shift and the arrival times on the final detector. No, well, the goal is a precision, I was wrong. The goal is a precision of 1% is better. The experiment has been approved by the CERN. There are several ENFN, Switzerland, France, Germany, and various laboratories in England, and so on, because there are several technologies. The problem with this experiment, that's difficult. Someone says that it not arrive to the goal because of the problem of cooling the antiprotons to very low temperature. So that will be one of the most difficult things. And then there's a problem of producing positronium in the silica. Then there's a problem, there's a magnetic field of 1 Tesla. So there are a lot of technological problems. I think the experiment will start at least 3 years. It won't end before 3 years. It can also be that it doesn't, for technological problems, well, it could arrive to success or not. But in the meantime, the other experiment arrive first, it could be interesting to compare the results. Questions?
Yes, this time I apologize. I have to make personal comments then this time and only this time. Michele, Dr. Sacerdoti, you have done a very accurate reproduction of what's going on at CERN, which we have to praise you. However, allow me to express extreme reservation on what's going on at CERN. And they have to be not officially on record, but at least you should know, because you come from countries providing lots of money to CERN. There are very severe ethical shadows, particularly on this issue, that you should at least be informed, at least in the terms that can be communicated. The CERN, the director of CERN has been repeatedly recommended to consider the testing of the positronium gravity by using the horizontal tube. They have systematically rejected the proposal by using sheer academic power at zero scientific content, just a sheer political act. The proposal has been submitted to the directorate at CERN of the horizontal tube for a very, very simple reason that Dr. Sacerdoti brought to your attention very clearly. There are many reasons, but the first one is this is a fuzzy experiment, extremely complicated, requiring lots of money, tens of, maybe hundreds of millions of dollars, of euros. By comparison, the horizontal experiment is resolutory. As compared to this one. So therefore, the question that we have to ask, if we are physicists or we are citizens of our country, why? Why this position by CERN of preferring a fuzzy experiment, extremely costly, over an experiment that is resolutory? But ladies and gentlemen, this is only the beginning of the problems at CERN. It's a conduction of science by total authority and very little science, with assassination, discreditation of any dissident view. There are very serious reasons that have been brought to the attention of the directorate that what they claim as being anti-hydrogen atom is not. Now, to understand this, I have to go back in time several years, regarding the synthesis of the neutron. As we know, the neutron is synthesized in a star from an hydrogen atom. And so until we reproduce in laboratory the synthesis of the neutron, ladies and gentlemen, our notion of the stars is just marginal. Now, the synthesis of the neutron is fundamental for what we are talking about here. It's because the neutron is synthesized from a proton and electron. Now, let's forget about all this political jazz, the quarks, and no, we're talking about synthesizing the neutron. Now, the CERN has systematically rejected this participate or even collaborate on the synthesis of the neutron, because the synthesis of the neutron violates brutally special relativity, quantum mechanics, because the rest energy of the neutron is bigger than the sum of the rest energy of the constituent. Schrödinger equation disappear. Then just considering the synthesis of the neutron at CERN means considering serious hadronic mechanics as a covering. But now the question, then eventually we did the synthesis of the neutron ourselves. This is the same as the ISO redshift. We were forced because either we care about knowledge or we don't care, let's become politicians then. Now, the question is the following. We did the synthesis of the neutron in laboratory repeatedly. As a matter of fact, there are physicists here who have been invited to come back and repeat it because we have the equipment. And here is the key point. Once you look at the seriously, in a quantitative way, no politics, cut the politics out, let's do the calculation and see how the neutron is synthesized from a proton and an electron, you see clearly, incontrovertibly, the finite probability of putting two electrons inside a proton. And once you put two electrons inside a proton, you end up with a particle that they believe is antiproton. But it's not absolutely certain. This is the issue. What they claim to have synthesized the proton is not certainly true. Now, putting two electrons inside the proton immediately was, but then the mass will be very big. There will be, first of all, it will be an unstable state. And you see all this is unstable. So regarding the mean life, we are squarely in what they do at CERN. But it's even for the mass, because sure, if you put two electrons inside the proton, you end up with half a mega MeV, which are a mass which is supposed to be bigger than, that's what they claim, bigger than half a mega, so we should detect the difference mass. This is not true. Not true, because in addition to the non-local, non interactions, there are also very strong electrostatic binding forces at that short distance, and those binding forces are indeed negative. So therefore, there are reasons to account that even the mass of this proton with two electrons inside could be very close to the mass of the proton. One final point that is at the root of all this. You have to see the mechanics. When you finally achieve a quantitative representation, as we did, of all characteristics of the neutron, all, not just the mass, including the anomalous magnetic moment, everything, you will see that this non interaction, for reasons that we do not know, they are strongly attractive. That's it is something that I don't know. I know from the equation. They have a very, very reward. The moment, that's the basis of our fusion. The moment we reach a certain point, especially if the coupling of the spin is proper, the spin are coupled in singlet, then instantly when you activate those non-potential interactions, they are strongly attractive. So therefore, the probability of that pushing inside this Rutherford, Professor Holland, this is in honor of Rutherford, this conception of the neutron, compressed hydrogen atom. The idea of compressing inside the proton 2 electrons is real, is absolutely real. So the risk, why I have to express my reservation regarding this experiment, not only because it's too fuzzy, but because if indeed at least some, or this what they claim to be an anti-hydrogen atom, is not certain. Because what they claim to be anti-proton could be a proton with 2 electrons inside, 2,000 times heavier than the positron orbiting around. I can assure you that entity will go down in the gravitational field and not go up for sure. So there is some of the physicists at CERN are under attack on this. Are you doing this in purpose because you already know that this thing goes up? Because you don't have the same problem that Fairbanks and his wife went under harassment not to do the experiment on measuring the gravity. Are we talking about a repetition of this thing? Until there is democracy at CERN, ladies and gentlemen, we have a very serious problem at the highest level of human knowledge that has to be addressed. So I want to be on record by expressing my extreme reservation. Professor John Ellis, former head of the theoretical division, invited me at CERN. You have no idea the problems that he has experienced because of that invitation. Just the fact that the alternative view could be considered at CERN is anathema. But ladies and gentlemen, this is not something that we scientists we should accept. I'm sorry. If I accept the situation without denouncing, I become an accomplice. I'm sorry, I cannot do that. So I want to be verbally, not in writing, but I want you to know there are very serious, extremely serious, motivated, with experiments, not with mumbo-jumbo theory, experiments that create very serious doubts on the very existence of the antiproton. At least that all of them are antiproton. Let alone the fussy, and then the fact to spend hundreds of millions of dollars on this fussy experiment. What's the reason it's going beyond all this, if not politics? Manipulating human knowledge. Ladies and gentlemen, it's a very dark moment in the history of science. It is, according to several people, we are living scientific obscurantism that is bigger than the obscurantism during Galileo's time. Because at that time, the obscurantism was because of a pseudo-ideological religious reason by the priest. Now we are talking about an obscurantism much, much darker. Talking about obscurantism with billions and billions of dollars of money and enormous interest on Einstein and this type of things. But we are living until there is scientific democracy for qualified inquiry, and there is the total suppression at CERN, at the Istituto Nazionale Fisica Nucleare that you mentioned, and also the other in British and the other country. Until there is scientific democracy, it is my opinion we are in an obscurantism. I apologize for this exploit, but I want you to know my feeling and my very unreassuring experience of suppression of just an ordinary scientific process. Thank you. Sorry, I apologize.
I appreciate it. In a very different way, I was going to raise questions about the Moore deflectiometry and what you might call the likely porous silica type of target. And it just is that there seems to be something of a contradiction between what you might call the Moore deflectiometry that you're working with and what you might call, you said also to the likely, the very porous type of silica target, and you said there was poor beam collimation. Well, it just means, unless I'm wrong, it just means is that you're going to have a big problem in terms of data control with all these three things put together.
So hydrogen atoms are coming, are being accelerated by the Stark effect, but they also will have a movement. So some of them will not go through the collimators. So the experiment needs to produce enough antihydrogen to have a significant number of anti-hydrogen atoms that go through the two slides. Not to yeah, well, what it is. Claimed anti-hydrogen. Claimed anti. But I don't understand. You claim that instead of what should that antiproton be instead? Yes. Mm. Mm. Yeah,
because this is a crucial point which has been communicated to CERN, and that's why I'm so upset. Let's again, you have to do the synthesis of the neutron. Synthesis of the neutron, where? As it occurs in nature, in a star.
But why the neutron here doesn't?
One moment. No, let me finish. But that's the first step. So you synthesize the neutron by embedding an electron inside a proton. Now, this process, which you have now achieved in laboratory, is a reality. It's now about to be reproduced. The same process apparently can embed two electrons inside the proton. Then you change the charge. From the neutron, you end up with a particle that has the mass of the proton, but the charge is negative, so they claim to be an antiproton. Now, they claim, no, it cannot be, because if you embed the two electrons inside the proton, then you have half a mega mass difference. It's not true. It's not a valid objection, because once there are two, the electrostatic interaction at that short distance are very high and imply a negative binding energy. So even the mass of this proton with two electrons embedded inside, even the mass is predicted to be very close to the mass of the antiproton. So it is not certain, and since you look at the process in which the claimed antiproton are produced,
a proton with two electrons.
With two electrons embedded inside, because it has been established that one embedding produces the neutron, and two embedding is as an unstable state, not a permanent state. Even the neutron has 15 minutes main life, but the main life of this pseudo antiproton but is in the range of several seconds, so way square.
It could stay.
Yes, it's good. The mass is very close to what they claim. The mean life is very close to what they say. But the point is this, ladies and gentlemen, this could create a distortion of science for 1,000 years. Because once CERN, with the credibility and the power that they have, the claims that this antiproton goes down, the science will be assassinated for hundreds of years before something is. This is, in other words, my primary irreconcilable disagreement with CERN. Otherwise, I become an accomplice to this manipulation. My point is expressed very clearly in this monograph that I quoted several times on the isodual theory of antimatter. We must, to do serious science on this fundamental, what is at stake is enormous for mankind. What we have to do, first we must measure the gravity of the positron and then do other experiments. In other words, I'm not necessary, because that we are certain that the positron is an antiparticle. Once we have established the gravity of the positron, then we can pass to more complex data under the condition, however, that we verify that what we claim to be the antiproton is a real thing. Now, namely in a direct annihilation process. In other words, I will accept that it is an antiproton if I see this annihilation on matter. They don't do that. They do not verify that they have an antiproton. They only claim that they will capture a positron. Of course, this type of proton with two electrons embedded, of course, will capture a positron. So it will look like an antihydrogen atom. It will look like, but it has nothing to do with an antihydrogen atom. Absolutely not. So in other words, but what is very unreassuring, why they don't want to debate this? Why did they prefer this fussy experiment over experiment, claim it to be resolutory, not by me, Ruggero, my God, I'm a theoretician, but very famous, including Mills, one of the best famous being resolutory. Why they prefer this fussy experiment? Maybe because of the suspicions, maybe you already know that the answer will be negative. That's the problem that Fairbanks suffer in this wife. So that's why these things have reached such an extreme situation. There's so much at stake for mankind. I cannot be silent. I become an accomplice to the. Sorry for the, because this is very, very serious. They suppress the scientific process. Dissident viewer trashed out. Until it's misogyn. They claim at one time I even had a beer. I never had a beer. That's, since they have no technical argument, that's the way they disqualified dissident view. Is it clear? I want to show you the calculation, the experiment. Come to Florida. We can show you experimentally, in addition to neutrons that come out, they remain particle, negatively particle, heavy particle inside the klystron. That those could be what at CERN claim to be antiproton. I do not, I am a scientist, I'm not a manipulator. I do not, Michele, I do not deny that some of them could be really antiproton. No, this is not the issue. No, the issue is there is so much at stake. This issue has to be resolved seriously, experimentally, and elaborating theoretically all alternatives. Then we pass. Then this is serious. Otherwise, they are heading for historical condemnation. Not during our 100 years from now, they will recognize that all this was manipulated. Sorry for I am Italian. I intend to express my feeling, but there's too much at stake here, and it's so sad that the scientific process is suppressed at the highest level of our knowledge in the world, which is CERN today.
I have a question also, but I will.
I appreciate this kind of lecture, and Professor Sacerdoti present very well what is work in CERN. I want only a small comment about the alpha experiment. Alpha experiment. The device, in fact, the device. The device of this type was invented in 1969 by Ioffe in Russia. And the idea of the time was to build a suitable magnetic field having a point with minimum energy, but without to be zero. Because in 1936, someone proved that is necessary such a point. The Americans spend a lot of time using a big magnet satisfying such a condition, but they never preserve the plasma around this point. And the idea of Ioffe was to put rectilinear wires near two anti-Helmholtz coils. And he succeeded. It was the first magnetic trap realized in the world. After that, being advised by a geophysician in my country, Saba Ștefănescu, very famous in geophysics, I studied such a device from geometrical point of view. And I reproved, of course, in my terminology, that it is a true magnetic trap. It's possible to preserve this plasma. And later, in my studies, I proceed in the following way. I use the electromagnetic energy, total electromagnetic energy, integral from, and constrained by Maxwell equations. What I discover? The electric field in such problem is like a control. It's possible to obtain an optimum, finding optimum electric field that produce a minimum energy, and then the optimal evolution, according to Maxwell equations, are solutions of Maxwell equations in Stokes form via potential of Stokes. So I think that also this direction can be analyzed because the control theory is very important in our research.
I have a question about the gravity experiment again. If the particle, let's call it X, is moving from the source where it's created onto the detector. It moves through these great things, and as I understand, you explained you assume that the particle which is created will travel following straight path. Of course, as the velocity is only very small, it's 500 meters per second maximal. You have to take the wave character of the particle into account. Also, even if it's have the weight or the mass comparable to a proton, there is still a wavy character. It means that at the edges of the diffraction gradient there will be diffraction, and it could be that this diffraction destroys the interference pattern which you are because I think what you are looking for, this is not really an interference pattern, but this is just an intensity pattern you are looking for, and you're looking.
Yeah.
But if you have diffraction, you will get interference, and it can destroy this intensity pattern. Maybe I don't know.
I think that the dimension of these slits is big to avoid any interference.
Yes, but if it's of course if it's too big, then your measurement is not accurate enough for
yes.
as it is. So I don't. The question is, of course, has that been taken into account? Do you know that?
No, I know it has been taken into account not to have quantum diffraction. So the dimension as such not to have. There was a slide I have taken away showing that there is no.
Okay, and the second question is well, no, it was related to the first question because you are using a dipole. Actually, you make a dipole, and that is what you are.
Yeah, because
which you are dropping.
Yeah.
And a dipole, of course, the quantum phase of a dipole could also be influenced by stray fields. Because so that could influence it also, but
yeah,
probably it will only influence it as far as the diffraction pattern, but you should it should be also taken into account then.
Yeah, I think so. I don't know. Well, I can't answer, but I think it has been. Okay.
No,
I'm not responsible for the experiment. From the document, it seems it has been. It has been taken.
Your presentation was very accurate.
So I hope.
Any other question? Important question? Okay, it's my job.
If you go on the Aegis experiment website, you will find probably all the details you need.
Yes, I think it's very important to relate to the objections from Professor Santilli here, that the possibility that these experiments that they will result in results that are wrong when interpreted from the framework of ISO dual theory of antimatter and hadronic mechanics, that while considering the much support from experiment and theory and calculations for the Rutherford-Santilli model of the neutron, and from hadronic mechanical theory about antimatter, then you will not really get any antiproton. It will have a negative charge, but the direction of gravity will be wrong because it will fall down and not go up. So my advice would be, due to politics, perhaps it's not possible, but to show some scientific decency here and relate to the quite different interpretation offered from hadronic mechanics, and that it's likely that it's premature to name this anti-proton.
Professor Johansen, I really appreciate you. That's why you are my friend. You are a very decent scientist. Thank you for your word. We are fighting here for scientific decency and scientific democracy, which is absent at CERN. At least they should present that their anti-hydrogen atom is a claim, subject to verification. But if it is certain that two electrons can be embedded in a proton for a short period of time, for an unstable state, for the duration of maybe of the order of certainly millisecond, but probably even this is certain. If now what is uncertain is the way they produce the antiproton. But from what I see, and they've never allowed me to go there because I'm in the blacklist there because I'm a dissident. But what I see, the process of which they produce the antiproton is very close to the process that we have used to synthesize the neutron. One neutron plus one electrons will produce what they claim the antiproton. However, your point, Professor Johansson, is true. That antihydrogen atom is made of what they claim antihydrogen is made of matter. The proton, this claimed antiproton will be 2,000 times heavier. It's matter. 2,000 times heavier than the real antimatter, which is the orbiting positor. So for sure, the thing will experience gravity. It's absolutely certain. I can prove it in any way you desire. So, but yet they have dismissed officially the consideration. There was even a recent accusation, because the head of CERN was invited to send an observer here. And has been officially under attack from the United States that you have refused to send any observer at this workshop precisely because you do not you prefer a fuzzy experiment. Those are the words used from America. A fuzzy experiment on anti-gravity as compared to what is a resolutory experiment with the tube. Why you prefer one or the other? And I understand there are movements now to suppress money. The only way to attack this type of manipulation, this suppression of democracy at the heart of science is with the money. Stop the money. In the United States, there are now senators, they just had it with CERN, and any additional funding is excluded. Unfortunately, Istituto Nazionale Fisica Nucleare is controlled from A to Z from CERN. So they can have from the Italian government any money that they want, and it's a control. I suspect the same thing in France. France is controlled by CERN. And sorry for the... You want to...
Of course, I don't see really the problem for CERN, because if they want to prove it's anti-hydrogen, just let it annihilate and measure the energy which comes free. Why not? It's a simple experiment. It's very easy to check if they are protons or antiprotons. So why don't? Yes. Because your suggested particle does not annihilate. So.
But this is the whole point. They have to prove. Thank you, Professor Dehan. This is the whole point. They have to prove beyond reasonable doubt that they indeed have antiproton, and this is your point. That I agree completely. The best way to prove it is via annihilation. And then once we are absolutely certain that it is antiproton, then yes, then everything that has been reported by Dr. Sacerdoti is correct. But there are doubts until verified. Otherwise, we are not scientists. This is what it boils down. The whole thing. It boils down to that point.
I have a very basic question, which is along the line which you argument. If you pump in 2 electrons into a proton in order to create whatever comes out then I see a spin problem. Is that a particle with spin 3/2?
No. This was the lecture by Professor Animalou, which is at the heart of astrophysics in our view. How do we synthesize the neutron? And if you assume that the proton is a point, that's what has been done. Fermi and of course Pauli, at that time they only knew the proton is a point. And then of course you have weak interaction, all this. But in reality the proton is extended and hyperdense. So when you compress the electron inside the proton, that's Rutherford compression, then what happened that since it is extended, the electron is forced to orbit around the proton with the spin of the proton, because otherwise the electron has to move against the hyperdense matter inside the proton, because the proton is 2,000 times heavier than the electrons. There is no chance. So the moment you compress the electron inside the proton, imagine this big sphere, the electron, the little guy, is forced to rotate around. This implies that the existence of a component in the synthesis of the neutron, which didn't exist in the 20th century, because 20th century quantum mechanics, that's all they did. But so you have an orbital component in the spin. When you look at this value is of the orbital component is 1/2. Now, and therefore, and this anti, because of the coupling has to be in singlet, so it's opposite to the spin of the electron. Conclusion, the total spin of the electron in what we call the Rutherford compression is 0, and the spin of the neutron is the spin of the proton. Now, incidentally, and this gives you the exact value of everything, including a normal magnetic moment, you represent the totality. Now, back to your question. You have now a particle with spin 1/2, and you force, which is the neutron. Neutral, you compress inside this structure and a second electron. You get essentially all the data of the antiproton. Yes, including very, very close, including, but there are variations, of course, but very at the level in which they work, they certainly don't verify those minute variations. But as far as the spin, the spin is this, because you have to look at hadronic mechanics. For instance, an orbital angular momentum with value 1/2 is anathema in quantum mechanics. Violates unitarity, it violates causality. So, but that's quantum mechanics, means everything points. The proton is a point. And once the proton is extended, hyperdense, and you look at the orbit, the isotopy of the orbital angular momentum, you see a fractional value of the orbital being absolutely fully causal. Conclusion, you do indeed reach a state that is very, very close. It should be investigated in details. And to answer your question.
Yes, but still I have then another question to that. Is the created particle then a real neutron or something which is a look-alike neutron?
Well, the neutron, the synthesis of the neutron is the first step. Neutron is a synthesis of the proton and an electron. Then you add to this structure, you add the second electron. And by adding a second electron, you got the charge of the antiproton, the negative, and the mass is very close. We don't even know as yet, because this thing nobody allows to publish. They will not even consider. But because the electrostatic interaction becomes very strong at those distances, so you have a very strong binding energy that can virtually nullify the additional half a mega electron volts of the second electron. So the mass is predicted to have to be very, very close. So we have a state that has the charge of the antiproton and the mass very, very close to that of the antiproton, but it is totally made of matter, not of antimatter. In other words, again, careful, because I'm not excluding that at CERN produce, because the way they manipulate my work, they twist and quote only certain things, and intentionally they do not quote the rest. My God, I'm not claiming that at CERN do not produce antiproton. My God, I'm a scientist. No. So for sure they produce antiproton. My point is that the antiproton claimed in the use of this experiment should be verified prior to this experiment. This Professor Dehaene, who is an experimentalist, serious experimentalist at that, should be verified, and once it's verified via an annihilation process, then the experiment is clean, becomes clean. Even though remains the enormous spend of money. Why they want to spend hundreds of millions of euro on a fuzzy experiment of unknown, when there are the solution universally by experimentalists admitted to be resolutory and much, much less expensive. But that's perhaps the problem, is because the test of the gravity of the positron is resolutory, and that's the only logical interpretation. I'm sorry, I wish I had another one. Because it is resolutory that there are problems of acceptance. You want to have
this second electron, does it go inside the neutron or it orbits?
No, penetrates. Because when you penetrate, think about the valence pair. You have two electrons in singlet that they form the valence. Now, according to quantum mechanics, those electrons, they repel each other because they have the same charge. But look at the strength. Let me touch you. Look at the strength. This is valence bond. So here you see a clear case in which I cannot accept quantum mechanics as a final theory, because it does not represent the strong attraction between identical electrons in the valence bond. So what is the only explanation that we did? I did this with Professor Schiller in academic chemistry, by introducing that when the wave overlap in singlet and only in singlet, you have a very strong, we got this from the equation, but if you ask me physically how, I do not know. But once you do them, it represents the wave overlapping of the wave packet in singlet cupping under a non-unitary, because those are non-potential interactions. On a non-unitary couple, you see a very strong attracting force, very, very determined. It's the basis of the valence. So think about, so if you have a valence pair, if you can embed one electron inside the proton and get a neutron, the embedding of a valence pair is ridiculous. It's so easy. We'll have, besides a zero spin, it will be much easier. The embedding of two electrons inside the proton may end up to be easier than the embedding of one electron alone. Yes, because of those interactions at short distance. And the size is 1 Fermi, because the strong interaction is 1 Fermi. You go anywhere beyond 1 Fermi, they're 0. The same for the valence bond, is you get 0, visually irrelevant.